Today we are solving basic log equations. There's a few things you need to know before you can start solving them. And the first thing that you have to be able to do is convert the log expression to exponential form. Because right now we're able to solve exponentials. We have a few tools in our belt for solving an exponential equation. We're then going to solve the equation. So to do step one, converting logs to exponential, what you need to do is understand that you can rewrite an exponential, which is this is your basic form for an exponential, like this. Each one of these, the b, e, and n, the ben here, represents the same thing over here. So if a number was in the base here, the number would be in the base here. So this is the regular look of a log equation. And there's three pieces to it. The base, this thing, this n, you can call it n for number if you want, but generally we call it the value. It's just Bev isn't the greatest name, so Ben makes a better name. And then e is for exponent. So what you notice here, the exponent here is what the log is equal to. And that's what you must understand. A log is an exponent. That's actually what it is. So whenever you're converting something to a log, that log should be equal to that exponent that you had to begin with. So there's lots of different ways to remember how to do this. Some teachers do the loops. I don't quite understand the loops. I understand that the exponent is here, and that's what the log is equal to. The b stands for base, and these two names are exactly the same. When I say this, I would say log base b of n is equal to e. So it's actually, we use the word base in the equation, so hopefully you understand that. Otherwise, it's log base b of n equals e. So a lot of teachers do that kind of loop thing. I don't really care how you do it as long as you remember how to do it. That's all. So b first, then the n, then the e. So here we are. I got an eraser somewhere. So here's the b first, then the n here, and then the e. So that's just the order you write them in. So that's what the loopy thing is. However you want to do it, it's okay with me. But you just have to be able to write one in terms of the other. All right, so there's two special cases. Talked a little bit about these two, the common log and the natural log, in the graphing video. But what you have to remember is if there is no base here, that means it's y equals log base 10 of x. So log base 10 of x. So the base is here. That's equal to the y. Now, the exponent is, the log is the exponent, and that's equal to the x. Okay, that's all there is. The natural log, remember, that's y equals log base e of x. So that's just ln, or natural log is it's not in, it's ln. It's just a shortcut way of writing this. So this is why I don't like the loopy things, because now I'm going backwards. But it's e to the y is equal to x. So we're going both ways here. So when I showed you here, right here, I went from the exponential to the log, and here I just went from the log to the exponential. So we're going to have to do both. But to solve log equations, we're going to generally do from log to exponential, but you do have to know them both. They're both useful. So this is the exponential. Can we write it as a log? Well, it's log, the base is 6, equals, of x is equal to y. This one, here's the x, that's your base. Doesn't matter what the base is. It's just, it's what the exponent is being raised to. So then we go to the k, and that's equal to the exponent. So the log is always equal to the exponent. The exponent should be by itself when you're dealing with a log. So remember, this is log base 10 of x, so here you have to go backwards, equals negative y. And remember, this is log base 10, so it's log of x equals y also. These two things are the same. You can write the 10 or not write the 10, it doesn't matter. And then here, log of p, log base p of t equals y. Going the other way. All right, going the other way. This is your base, 2 to the x equals y. So remember this one, the one that's by itself, the one the log is equal to, that's always your exponent. Remember that this is your base, 10 is your base here. Log is equal to the exponent. There we are. Then remember this is log base e. So it's e to the x equals y. And then it just should be x to the z equals y. All right, so you have to be able to go back and forth with relative ease. So try that out and make sure you will practice a little tomorrow. Evaluate this. There's two ways to evaluate this. One of the ways is just literally plugging it into your calculator. So you remember it should be alpha, I think in the other video I wrote. So it's alpha window 5. Yeah, I think I wrote second, but it should be alpha window 5. Okay, so this is equal to x, but you could type this into your calculator and just evaluate it. The other way is to know that this is equal to x and do 27 to the x power equals 1/9. Change the bases so that the same. 27 is 3 to the third. 1/9 is 3 to the -2. And then solve the resulting equation, which would be -2/3. Okay, but like literally plugging it into your calculator for this one, you would just plug in log base 8 of 32. When they're this straightforward, you can do that, but also changing the base would work also. Here's more equations, just trying to solve each equation for x, and we do have to check for values that make the function undefined. All right, so we'll go through and check and see how it works. So the first thing we want to do, if we have a log equation, is change it to exponential. So it's 4 to the 3 equals x. So you get a lot of practice doing that kind of thing. Evaluate 4 to the third, you get 64 equals x. The check is this guy right here, wherever x is. It's either going to be the base or the value. So remember the base, it has to be greater than 0, and it can't equal 1. So it's a little weird. It's a hard way to go. There's no real nice way to say that. It just has to be greater than 0 and not 1. And then the x, the value, has to be greater than 0. So remember, this is the value, and this is the base. So you just have to check, is 64 greater than 0? Yeah, so that checks. Next. So we do, again, we want to change the 6 is the base, 2 is the exponent, equals x times x minus 5. So it's 36 equals x squared minus 5x. I'm going to let you solve this for time's sake. All right, so here we have, I solved it here. I got 9 and -4. I checked it. I made sure that the base here, not the base, sorry, x is not in the base, 6 is in the base, correct? So I needed to check that the value here is greater than 0. So I plug 9 in for x to make sure it's greater than 0, and it is. I plug -4 in for x, and it's greater than 0. So we're good, both of the values work. Alrighty, for this guy, we have a bunch more equations here that we have to solve. So I don't want to focus on solving the equations. I do want to focus on the actual log part. So I'm going to do the log part and then break to the actual answer. I'll have the work there, but you'll have to try that out on your own. I'm sure I'll pause it to make sure you do that. So I'm going to change it to exponential form. 27 to the 4/3 power is equal to 2x minus 1. All right, take a second and solve it. Dun, 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 dun. All right, this is me solved. I got 41. I do have to check. Now, since I'm checking the value here, that value has to be positive. Nothing else really matters there. You can check the whole thing to make sure it works in general. However, 81 is greater than 0, so the value works. Okay, so now let's do this one. Let's switch this log. So this is the base this time. 5x minus 1 to the 1/3 power is equal to 4. All right, try it out. All right, so hopefully solving this was pretty easy. Remember, flip the exponent and then solve. Okay, it was an even, so we didn't have to worry about the plus minus thing. All right, now we check. This is the base this time. So the base has to be greater than 0, but it also can't be 1. So you do have to check to make sure it's just not 1. It's a. All right, so let's check 13 and make sure 13 works. Is 13 makes that value greater than 0 and also not 1. It's 64 is greater than 0. That works. Down here, it's just an interesting problem. Just got to do some thinking. You just have to solve each one of these. Find the numerical value of x divided by y. So basically, you're going to figure out what this value is. Switch it around, and this becomes 32 is equal to x. And this one here is y to the negative 3 over 2 equals 125. Flip the exponents, and you get y is 1 over 25. Okay, now those are the two answers. That's what x is, that's what y is. But what you have to figure out is what is x divided by y. So x is 32, y is 1 over 25. Simply do the math, and it's 800. So it's just a little extra something for you to figure out and trick you, and we're wonderful at that. You're welcome. So here we are. Last one here. I should let you do it on your own, huh? So switch it, x plus 3 squared, so the base to this, is equal to x cubed plus x minus 2 over x. So it's a lot of stuff, but it's still pretty basic. It's still the same old flip. It's this to that power equals that. So you just have to now have to do the math. So give it a try. Square this first, and then I'm going to give you a hint. Cross multiply and see if you can solve that and check. So we'll just take a second here and stop. This is the equation that I got. Hopefully you got this far. You may want to give it a try and then make sure you got the right things from here and then finish this problem. Okay, so hopefully it's not too messy for you to read. I got negative 1/3 and negative 1. Pause it, take a look at it if you're not quite sure. If you can't tell. Then I had to check both of these values. This one was a very interesting problem. So I had to check both of those values in the base and make sure the base is greater than 0 and not 1. And then I had to make sure this value here was greater than 0. So I actually had to do 4 checked. And they both worked. So with negative 1/3, I got 2 2/3 is greater than 0. 2 is greater than 0, and they're both not equal to 1. So those two check. And then when I come down here in that other mess, I simply have to check if negative 1/3, if I plug that in, if that's greater than 0, it was. And if this one was greater than 0, it was. All right, so have a fantastic day.